This video is going to run through slope, just a review of slope. Visually, what is slope and counting out slope. So before we get started, the little triangle means change. The little delta, the Greek letter delta means change. So I'm going to use that whenever I'm describing what's happening. We're going to think about slope as a rate of change. And a way to think about slope is the change in y over the change in x. You may have heard rise over run. And then I'll give you a little visual here. It's the vertical change over the horizontal change whenever you're looking at the change between points that are plotted on a line in the xy plane. On a linear graph, this rate of change is called the slope of the line. And slope is always written as a ratio. And it's written as a ratio of the vertical change, and I'll use my little symbol, my delta, change in y, to the horizontal change, the change in x. So it's the ratio of the vertical change to the horizontal change between any 2 points on a straight line. And this rate of change remains constant between each point that would occur on the line. Slope is written as a fraction, and it's always written as a fraction given in its simplified form, its most simplified form. And the lowercase letter m is the variable that represents slope in linear equations and linear functions. So let's look at types of slope. So I want you to draw the 4 little axes in your notes. The first slope that we look at is the positive slope. And positive slope occurs whenever a line rises as you move from left to right. If the line is rising, that's considered a line with a positive slope if you're climbing up. A negative slope as you look at the plane from left to right, a negative slope would be a line that's falling from left to right. Then you have zero slope. Zero slope is for the flat line, the flat horizontal line. And then we have what's called no slope at all. No slope or undefined slope, and that's reserved for the vertical line. So here's a visual layout. Positive slope if you're climbing up, negative slope if you're moving down, zero slope for your flat line, and no slope or undefined slope for your vertical line. So all you're going to do in this particular problem set is just simply count between plotted points to determine the slope of the line. So we're finding the slope from a graph. And as I do that, I would just jot this down. Positive motion is up and to the right. Negative motion is down or to the left. So vertically moving up is positive, horizontally moving to the right is positive, vertically moving down is negative, and horizontally moving back to the left is considered negative motion as well. So I've highlighted the points. Some of the points did not photocopy well. So I've highlighted the points here on my graph, and I'll zoom in, and I'm just going to count between plotted points to determine the slope. So I'm first going to count up. So I'm finding my slope. So I'm going to write m equals, and I'm going to give myself a fraction bar. The numerator of my slope is going to be my vertical change. So I'm going to count between the 2 points. So I'm getting a numerator of 7, and then I'm going to count over. 7 over 4. I see that this line is climbing as I move from left to right, so this slope is positive 7 over 4. Moving to number 2, I'm going to do the same thing. I'm going to give myself m equals and a fraction bar. And I'm going to start at this point and count up. So my numerator is 3, and my denominator counting over, and up is positive, but now I'm going to count back to the left, so that's going to be negative. Counting to the left, negative 9 units. I need to simplify this, so the slope for this line is negative 1 over 3. The graph in number 3, there's no vertical movement, it's just simply horizontal movement. So this is the case where the slope is 0. This is my horizontal line with the slope of 0, and the example in number 4, there's no horizontal movement, it's just simply vertical motion. So this is the no slope line or undefined slope. No slope, undefined slope, meaning the same thing. So what I would like for you to do, I would like for you to look at the graphs on the next page and just simply determine the slope of each, just counting between the points. Should be fairly simple exercise. And I will do, this is upside down, I will do, I'll just do number 12 because it's on the screen, and then I will stop the video. So I want you to do exactly what I did. M equals, give yourself a fraction bar. I'm going to count up first, 2 units up, that's my numerator, and I'm counting up, which is positive, and then counting to the right, which is also positive. And so the slope for this line is 2/3.